Hello everyone, in this video I'll be discussing about analysis and design of algorithms, in which I'll be explaining about insertion sort, pseudocode and algorithm for it and its efficiency by taking an example. Then I'll be discussing about topological sorting, in which Khan's algorithm and depth first search and its efficiency, algorithm and pseudocode. Introduction to insertion sort. Insertion sort is a simple and intuitive sorting of algorithm which builds the final sorted array in item at a time. It is much like the way you might sort playing cards in your hands. Algorithm for insertion sort. First step is start with the second element as the key, element at the index 1, and compare the key with the elements in the sorted part, means left side of the array. Then shift all the elements greater than the key to the right and insert the key into the correct position. Then repeat these steps 2 to 4 for all elements in an array. The pseudocode of the insertion sort is represented here. You may take a look on this. Then let's take an example for this. Consider the array consisting 5, 2, 9, 1, 5, 6. Then first step is initial array, means the given question 5, 2, 9, 1, 5, 6. First step is first pass, means I equals to 1, where key is 2. Compare 2 with the 5. Then shift 5 to the right. Then insert 2. The result will be 2, 5, 9, 1, 5, 6, where we shifted 2 to the left side, means 5 is shifted to the right. Then second pass I equals to 2, where key is 9. No shift needed. Result 2, 5, 9, 1, 5, 6. Then in the third pass I equals to 3, key is 1. Then shift 9, 5 and 2 to the right. Then insert 1. The result will be 1, 2, 5, 9, 5, 6. Then fourth pass I equals to 4, where key is 5. Then shift 9 to the right. Then insert 5. For fifth pass I equals to 5, where key is 6. Then shift 9 to the right. Then insert 6. Efficiency in insertion sort. Time complexity, in which best case, average case, worst case and space complexity. Best case, here big O of n when the array is already sorted. In average case, big O of n square due to the nested loops. In worst case, big O of n square when the array is sorted in reverse order. Space complexity, O of n as it sorts in the place and requires no additional storage. Topological sorting. Introduction to it. Topological sorting is an algorithm for ordering vertices in a directed acyclic graph (DAG) such that for every directed edge u minus v, vertex u comes before the vertex v in the ordering. Types of topological sorting. There are two types: Khan's algorithm and depth first search. For Khan's algorithm is calculate in degrees of all vertices and then NQ all vertices within 0 degree. Third step is while the queue is not empty, DQ a vertex and add it to the topological order. Then decrease in the degree of its neighbors by 1. If a neighbors in degree becomes 0, then NQ it. Pseudocode will be represented like this. Then depth first search, DFS based. Algorithm is perform DFS on each vertex. Then on visiting a vertex, mark it as visited. On finishing a vertex, add it to a stack. Then the stack will contain the vertices in topological order when all vertices are processed. Pseudocode for this will be represented like this. Let's take an example for topological sorting where we consider a graph representing like 4, 0, 5, 2, 3, 1. In Khan's algorithm, we'll be taking steps like first step is in degrees 0, 1, then 1 to 1, 2 1, 3 1, 4 to 0 and 5 to 0. Then NQ 4 and 5. Then DQ4 process its edges, update in degrees. Then fourth step is DQ5 process its edges, update in degrees. Then continue until the queue is empty. Like this the Khan's algorithm will be working. When we take depth first search first, start DFS from 5, then visit 0, then 1, then backtrack. Start DFS from 4, then visit 0 and 1, which is already visited, then backtrack. Then visit 2, then 3 and backtrack. Like this the DFS will be performed. Then efficiency is time complexity, big O of V plus E, where V is the number of vertices and E is the number of edges. For space complexity, O of V for the storage in degrees and the stack. Graph representation, adjacency list. You can see the code here. Then adjacency matrix. Example for it.